Lesson 33, we're going to do in two parts. First, horizontal circles and then vertical circles. Horizontal circles are pretty easy. Vertical circles are definitely more complicated. And as it says in your notes here, the tough part is figuring out how to set them up. Because what you need to do is you have to ask yourself what's causing the circular motion, or what's causing the centripetal force. And as alluded to earlier, horizontal circle problems, it's usually pretty easy. We're usually talking about a car going around a traffic circle or just a car going around a bend. And if you're going to be a civil engineer, this is going to be very useful for you because you would actually have to do something like this to calculate how wide. Well, let's just look at this example here. It's a great example. A construction team is looking at building a turn on a highway road. They are concerned the car should be able to go through the turn without skidding off the road, even if conditions are bad. Determine the minimum radius that can be used for the curve of the turn if the car is traveling at 110 kilometers per hour. And might be traveling in conditions that cause a coefficient of static friction of only 0.6 between the tires and the road. It should probably be kinetic friction since you're moving, but we won't be picky about that. So just to remind you, anytime here's the different trail. Right there it is, and it has a lot of curves, and every one of these curves represents a circle. There's a circle. There's a circle there. There's a circle there. There's a big circle there. There's a circle there. So they all represent circles, even though we're not going in a circular path. And as I said, the first thing we're going to have to do is determine what's causing the centripetal force. And in these problems, it's the force of friction. So the centripetal force has to be equal to the force of friction. Because if there's no friction, it's no friction of your tires on the road, you can't go in a circle. How does that work? Well, the friction, the tires push outward on the road, and therefore the road pushes you inward. We should write that down. The tires push outward. This is when you're trying to make a turn in a car and your wheels turn to the left, for example, so they are pushing to the right, outward on the road, and then the road turns around. The road pushes the tires inward, right? And once again, we're back to Newton's third law. For every action, there's an equal and opposite reaction. The tires push outward on the road pushes you inward. Okay, so let's go back to this formula here. The centripetal equals the frictional force. We've already determined the formula for the centripetal force is mv squared over r. And the friction force from the last unit is going to be mu Fn. We have the coefficient of friction. We need to know what Fn is. Well, if your car is on the road, here's your Fn. It's going to be equal and opposite to Fg because the car is not accelerating in a vertical direction. So we can, well, first of all, what are we solving for here? We're solving for the radius. So let's expand that formula first and change this to mg, because Fn and Fg are equal and opposite. Therefore, Fn equals Fg and Fg equals mg. And something interesting here happens, which should be very intuitive. What cancels out? The mass. And I say that should be intuitive because if that was not the case, if the mass didn't cancel, you would have to have a different speed limit for every different mass that went around a corner. So the mass is irrelevant in this problem. Thank goodness. That would be terrible if you had to have that many speed limits for all the different car masses or truck masses. The mass cancels out, and then we solve for radius. All right, and then it becomes from that point on, it becomes a pretty straightforward problem. We have the velocity, 110 kilometers per hour, which we can convert to meters per second. You have the coefficient of friction, 0.6, and you have the gravity. And if you stick that into your calculator, you turns out you get an answer of 160. 160 meters. So that has to be the radius of the curve on this highway. It must be, so it has different. Oh, there's the curve. So that if that was the curve right there, then there's the circle. In other words, this would have to be 160 meters. Okay, so pretty straightforward for horizontal circular program problems. We'll stop this video, start another one for vertical, because vertical problems are far more complicated and thought-provoking.